Hello everyone. Today we are presenting our project on face recognition based attendance system. I am Sarvitha Shekhawat and I was responsible for the AI part of this project. Now let's start with the problem statement. As we all know that manual attendance takes a lot of time which reduces actual teaching time. Secondly, there is a problem of proxy attendance where students marks attendance for others as well. Third, in large classrooms, managing attendance becomes difficult and inefficient. And lastly, manual attendance systems often have human errors like wrong entries or spelling mistakes. So overall, the current attendance system is slow, inaccurate and not even reliable. Now let's look at the objective of our project. The first objective is to improve accuracy. Our system should correctly identify students with minimal errors. The second objective is real-time detection. This means attendance should be marked instantly during live sessions. Another important objective is to prevent proxy attendance. Only the actual person present should be marked using face recognition. We also aim to automate the attendance process completely, so there is no need for manual marking. This helps in reducing human effort and saving time for teachers. Finally, our system supports multiple faces at once, making it suitable for classroom with many students. So overall, our goal is to create a fast, accurate and reliable attendance system. Now let's understand how our system works step by step. Step 1 is video capture. The camera continuously records live videos from the classroom environment. Step 2 is face detection. The system scans each frame and detects all the faces present. It can detect multiple faces at the same time. Step 3 is region extraction. After detecting faces, the system isolates only the face portion from the image so that it can only focus on important details. Step 4 is embedding generation. Here, the system converts each face into numerical data, also called embeddings. These embeddings represent unique facial features. Step 5 is database comparison. The generated embeddings are compared with the stored data of registered students in the database. Step 6 is threshold check. The system checks how similar the new face is to the stored data. If the similarity is above a certain limit, it is considered a match. Step 7 is identity display. If a match is found, the system shows the name of the person, and if not, it marks the person as unknown. Finally, step 8 is attendance marking. Once the person is recognized, their attendance is automatically recorded in the system. So overall, the entire process happens very quickly without any manual effort, which will end up saving teachers' time as well.
Hi, my name is Asra. I worked as a front-end developer in our project. Let us look at the technologies used in our project. First, we used Python as a main programming language. It provides base structure, building entire system, integrating all components. Next, we used OpenCV, which is computer vision library. It helps capturing video, detecting faces, and processing images in a real time. We also used DeepFace, which is deep learning based face recognition framework. It is responsible for identifying faces accurately by extracting important facial features. Then we used NumPy, which is numerical computing library. It helps handling errors, performing mathematical operations efficiently. Finally, we used MongoDB for storing our data of student facial numerical vectors, student queries, and class sessions, and database is connected to the student, teacher, and admin portals, and it is ensured that the access of data according their roles. Insert abstraction, it is done properly. All the technologies work together to make our system fast, accurate, and efficient. Technologies used slide. Thank you.
Now let's talk about implementation of a system. Our project is divided into three main modules. The first module is capture faces. This module is used to collect images of users. It captures multiple images of each person and label them properly. This step is important because good quality data improves the accuracy of the system. The second module is generate embeddings. In this module, the collected images are processed using deep learning models. The system converts each face into numerical data, which we call embedding. These embeddings are then stored for future comparisons. The third module is mark attendance. This is the main module of our system. It works in real time by capturing video through camera, detecting faces, comparing them with stored embeddings, and automatically marking attendance. So overall, first we collect data, then we process it into embeddings, and finally we use it for real-time marking. This module approaches make our system organized, efficient, and easy to manage. Now, let's look at the result and key features of our system. First, our system provides real-time detection. This means it can recognize face continuously during live sessions and give instant feedback without any delay. Second, the system achieves high accuracy. It matches face very precisely with very few errors like false positive and false negative. Third, it supports multiple faces at the same time. This means it can detect and recognize many students together in a classroom environment without any issue. Because of these features, our system is fast, reliable, suitable for real-world use. Overall, the results show that our system can efficiently automate attendance while maintaining accuracy and saving time.
Hello guys, I am Mayank Gupta. Hope you are doing good. I have done the database part of this project in which I have used MongoDB. I am going to show you some database insights and then we will move to the challenges part. First I will show you some database insights, how it's looked like. These are the collections I have made. The first collection, attendance summary, contains the summary of attendance, and the edit logs contains the edit that admin made, and the queries log queries collection contains the queries, and the session contains the classes, and the collection of student contains the face data of students. I'm gonna show you some data sets like what we have in our student collection is this. We have some these are them 128 dimensional vectors of my friend's face. Like we have 5-6 faces here for now. Now I'm gonna switch to the challenges part. Like what are the challenges are we facing now, or what are the future enhancements of our system. First, talking about current limitations, one challenge is lighting sensitivity. The system performance can change under different lightings, like very low lighting or very bright light. Okay, second is the database quality. The system needs good quality and diverse training data to perform accurately. If the data is limited, accuracy can be affected. Like we need to have as much as photos and vectors we can, so that the efficiency can be increased. Third is the angle dependency. Like if your face is like this or this, or your face is not clearly visible or at an extreme angle, the system may not recognize it properly. Another issue is occlusion. If the face is partially covered, like you are sitting like this, or you are applying a mask, or like you are you have glasses, so its recognition becomes difficult sometimes. Finally, the system requires more hardware, like a good camera and sufficient processing to power efficiently. Like we definitely require a 4K or 2K camera for a whole class to work it efficiently. Now coming to future work, we can improve the system by developing a mobile application so attendance can be marked using smartphones. Okay, we can also use cloud infrastructure to store data, making the system more scalable and accessible. Another improvement is using more advanced models to increase accuracy and performance. We can also create an analytics dashboard to visualize the attendance data in a better and more useful way. So while our future system works effectively, there is a scope for improvement and expansion in the future. Our system is working fine now, but there are still lot many scopes to improve this system, to increase its efficiency and lot. So with this I would like to conclude this session. Hope you liked our project. Please give your feedbacks in comment section and let us know what else we can add this, or your idea, your POV we all want to